All right, so get this. We're diving deep into all the research that you sent in on quantum computing and AI.
Exciting stuff.
It's not just theoretical anymore. I mean, you sent in some seriously cutting edge research, including excerpts from this paper.
Yeah,
It's called Quantum Computing and Artificial Intelligence, a Synergistic Future. It's pretty wild to see how fast this field is moving.
you're absolutely right. And what's particularly interesting, I think, about all the research that you sent in
Yeah.
is how much of it is focusing on specific applications.
Yeah.
It's not just talking about the potential anymore. We're
Mm.
seeing tangible examples of how these two technologies are already starting to make waves.
Okay, so no more sci-fi hypotheticals. We're getting down to brass tacks.
Yeah.
And one thing that really jumped out at me was this paper's discussion of using quantum algorithms to speed up drug discovery.
Yes, and
Yeah.
your research specifically highlights the development of a quantum algorithm for simulating molecular interactions,
Okay.
which could totally revolutionize how we design new drugs.
That sounds way beyond my chemistry knowledge.
Yes.
Can we break that down a bit? What makes quantum computers so much better at this than our everyday computers? I mean,
Yeah, it all boils down to the fundamental difference between bits and qubits.
right.
So classical computers use bits, which can be either a 0 or a 1,
Mm-hmm.
but quantum computers use qubits, which, thanks to this wild concept called superposition,
Right.
can be both 0 and 1 at the same time.
Okay, superposition. I remember reading about that. It's like a qubit can be in multiple states at once.
Exactly.
But how does that actually help with something as complex as drug design?
Well, think about simulating a molecule.
Okay.
You're dealing with tons of electrons
Right.
interacting in super complex ways.
Uh-huh.
A classical computer has to calculate each interaction separately,
Okay.
which takes a massive amount of time and computing power.
Yeah.
But a quantum computer, by leveraging superposition,
Yeah.
can explore all possible interactions simultaneously.
So it's like a massive shortcut. It's cutting through all the clutter to get to the answer faster.
Exactly. And this speed advantage is absolutely crucial when you're talking about simulating complex molecules for drug discovery.
Right.
What might have taken classical computers years to calculate, a quantum computer could potentially do in a matter of days or even hours.
So we're not even just talking about making things a bit faster.
Yeah.
We're talking about potentially unlocking cures for diseases that have plagued humanity for centuries.
That's the ultimate goal.
Yeah.
And while we're still in the early stages of this quantum revolution, the potential is truly staggering.
Yeah. My mind is officially blown.
It's pretty amazing.
But let's shift gears a bit
Sure.
and talk about another concept you mentioned earlier, entanglement.
Okay.
I remember reading about this in one of the articles that you sent over.
Yeah.
It's this idea that two qubits can be linked
Yes.
in a way that they influence each other instantaneously no matter how far apart they are.
Exactly.
Uh-huh.
It's pretty mind-boggling.
Yeah, one of the articles even called it spooky action at a distance. Yeah.
Which sounds like something straight out of a science fiction novel. But how does this entanglement actually factor into things like drug discovery?
Entanglement allows quantum computers to perform these complex calculations that would just be impossible for classical computers.
Okay.
So remember that drug design algorithm we were talking about?
Yeah.
It relies heavily on entanglement to simulate that intricate web of interactions between electrons in a molecule.
So it's not just the speed of the individual qubits.
Right.
It's their ability to work together in this interconnected way.
Precisely. Entanglement is like the secret sauce that allows quantum computers to achieve these exponential speedups for certain types of calculations, making them perfect for tackling complex problems like drug discovery.
Okay, so we've got superposition, which lets qubits be in multiple states at once.
Yep.
And entanglement, which links them together in this spooky, super efficient way.
You got it. And
Mhm.
together, these two concepts, they form the foundation of quantum computing and unlock this just incredible potential for transforming fields like drug discovery and so much more. This is all pretty complex stuff. It seems like building a quantum computer that can actually harness these principles must be incredibly challenging.
It is.
One of the articles you sent over talked about the current state of quantum computing, and it mentioned that we're still in the really early stages.
Yeah, that's an important point. Building stable and scalable quantum computers is one of the biggest hurdles in this field.
Mm-hmm.
One major challenge is maintaining that delicate state of superposition and entanglement,
Right.
which can be easily disrupted by environmental noise.
Oh, wow.
And this is where error correction comes in. This is a critical area of research that focuses on mitigating those errors and ensuring the reliability of quantum computations.
So it's like trying to build a super fast race car out of the most delicate materials imaginable.
That's actually a great analogy.
Yeah.
Despite these challenges, though, the progress in the field has been remarkable.
Okay.
The paper you shared highlights several promising approaches to error correction,
Hmm.
including the development of these topological qubits, which are thought to be more robust and less prone to errors than other types of qubits.
It sounds like there's a lot of cutting edge research happening in this area.
Absolutely.
And the race is on to build a quantum computer that can truly live up to its potential.
Yeah, the pace of innovation is incredibly exciting.
Okay, so we've covered some pretty heavy stuff: superposition, entanglement, error correction, and we've touched on the incredible potential of quantum computing for drug discovery.
Yeah.
But I'm curious, beyond this specific application, how else is quantum computing poised to revolutionize the field of AI? I'm eager to delve into some of the other research that you've shared.
Well, one area that's particularly fascinating is the potential of quantum machine learning.
Hmm.
And your research specifically touches on this.
Okay, this is where it gets really interesting. I'm ready to dive into that. But before we go down that rabbit hole, let's take a quick pause here. Welcome back. Last time we were just geeking out about how quantum computers could totally speed up drug discovery.
Yeah.
But you also sent in some research on quantum machine learning.
Mm.
And that's like a whole other level of awesome, right?
It really is.
Huh.
And what's so fascinating is that your research highlights how quantum machine learning could revolutionize fields beyond healthcare.
Okay.
Like one area that stood out to me was its potential impact on cybersecurity.
Cybersecurity. Okay, that's
Yeah.
not something I would have immediately connected with quantum computing.
Yeah, it might seem surprising, but a lot of our current cybersecurity relies on encryption algorithms
Mm-hmm.
that are complex for classical computers to crack.
Right.
But quantum computers, with their exponential speedups, could potentially break these codes much faster.
Oh, wow. So it's like a double-edged sword.
Exactly.
Quantum computers could be used to create unbreakable codes, but also to break existing ones.
Right. And your research dives into how quantum machine learning can be used to develop new quantum-resistant encryption algorithms.
Okay.
It's like an arms race between quantum code breakers and quantum code makers.
That's pretty intense. It sounds like we need to be developing these quantum-resistant algorithms, ASP, if we want to stay ahead of the game.
Absolutely. And the research you sent in delves into some really innovative approaches like using quantum entanglement to create encryption keys that are virtually impossible to intercept.
Okay, so basically we're using the weirdness of quantum mechanics to create a new generation of ultra-secure communication.
You got it. It's a fascinating intersection of quantum computing, machine learning, and cryptography. And it has huge implications for everything from national security to personal data protection.
I have to admit, I'm starting to see quantum computing everywhere now. It's like it's going to touch every aspect of our lives.
It really is a game changer.
Speaking of which, you also sent me some research on how quantum computing could revolutionize financial modeling.
Yeah, financial modeling is another area where quantum machine learning could have a huge impact. Your research specifically highlighted the use of quantum algorithms for portfolio optimization,
Okay.
which is that process of selecting the best mix of assets to maximize returns and minimize risk.
So it's like using quantum computing to outsmart the stock market.
Well, it's not quite that simple, but it's true that quantum algorithms could potentially analyze vast amounts of financial data
Yeah.
and identify these subtle patterns that are invisible to classical algorithms,
Right.
leading to more accurate predictions and better investment decisions.
So it's not just about picking stocks, it's about understanding the complex interplay of factors that drive the market.
Exactly. Quantum machine learning could help us develop financial models that are more sophisticated, more nuanced, and ultimately more accurate, leading to greater stability and efficiency in the financial system.
That sounds like it could have a huge impact, not just for individual investors, but for the global economy as a whole.
Absolutely. And your research highlighted how quantum computing could even be used to develop new financial instruments and markets,
Really?
potentially opening up entirely new avenues for economic growth.
I'm starting to feel a little overwhelmed by all the possibilities here.
I know it's a lot to take in.
Healthcare, cybersecurity, finance, it seems like quantum computing is going to touch every industry imaginable.
It's pretty remarkable.
But I also remember reading in your research that there are still some significant challenges to overcome before we can fully realize this quantum future.
That's right. We've talked about error correction, which is still a major hurdle.
Uh,
But another challenge is the development of scalable quantum computers.
okay.
The quantum computers we have today are still relatively small and limited in their computational power.
So we need bigger and better quantum computers before we can tackle the really big problems.
Exactly. And building larger, more powerful quantum computers requires overcoming significant engineering challenges.
Yeah.
One approach that's gaining a lot of traction is the development of superconducting qubits,
Okay.
which are essentially these tiny circuits that can be manipulated to store and process quantum information
So it's like we're trying to build the most complex and delicate circuits imaginable,
with quite a feat.
all while keeping them at these ultra low temperatures to maintain their quantum properties.
You got it. It's an
Yeah.
incredibly challenging engineering feat, but there's some brilliant minds working on this problem.
Yeah.
And we're seeing steady progress in terms of both the size and stability of quantum computers.
Okay, so bigger and better quantum computers are on the horizon.
They are.
But for now, we have to work with what we've got.
Right.
And that brings us back to the concept of these hybrid models, right?
Yes. Hybrid models are a crucial stepping stone on the path to fully quantum-driven AI.
Mm-hmm.
By combining the strengths of classical computing with the unique capabilities of quantum computers, we can start tackling real-world problems today.
So it's like a tag team approach, where classical computers handle the tasks they're good at, and quantum computers step in for the heavy lifting.
That's a great way to put it. And your research actually highlights a fascinating example of this in action.
Oh, cool.
There's a project underway that's using a hybrid quantum classical approach to develop new materials for solar energy.
Okay.
The quantum computer is used to simulate the behavior of electrons in different materials, while the classical computer handles the data analysis and optimization.
So they're basically using quantum computing to design super efficient solar panels.
Exactly. It's a great example of how we can leverage the best of both worlds to address real-world challenges today while we continue to push the boundaries of quantum computing.
Okay, so we've got error correction scalability and these hybrid models. These are some pretty big challenges.
Right.
But one thing I've noticed in all the research you've shared is this incredible sense of optimism and excitement about the future of quantum computing and AI.
Yeah, there's a real buzz in the air.
Yeah.
There's a real sense that we're on the cusp of a technological revolution, and everyone's eager to be a part of it.
Yeah.
And I have to say, the research you've gathered is a testament to that.
Well, I'm feeling pretty inspired myself. But before we get too carried away with all the possibilities, I want to take a step back and make sure we're all on the same page.
Sure.
I mean, we've covered a lot of ground today,
Okay.
from drug discovery to cybersecurity to financial modeling.
You're right, we've been on quite a journey.
Yeah.
Perhaps it's time to reflect on the key takeaways and consider what this all means for the future.
I like where you're going with this. Let's shift gears and delve into what this quantum future might look like. But let's save that for our final part.
Okay, so we're back. And we're ready to tackle the big question. What does the future really look like with quantum computing and AI working together?
Right, because we've talked about all these really specific examples.
Yeah.
But zooming out, what's the big picture here?
Yeah, exactly.
Well, the research that you've shared paints a pretty compelling vision.
Okay.
One recurring theme is this idea of a world where complex problems that are currently intractable for us become solvable.
Okay.
We're talking about challenges like climate change, global pandemics, and even the search for extraterrestrial life.
Whoa. Okay, so we're not just talking about incremental improvements. We're talking about potentially solving some of humanity's biggest challenges.
Yeah, it's pretty amazing.
That's a lot to process.
It is, and it's important to remember that this is a long-term vision.
We're still in those early stages of this quantum revolution, but the potential is truly transformative.
One specific area that caught my eye in the research was the potential for quantum AI to revolutionize climate modeling.
Yeah.
I mean, right now our climate models are pretty good, but they're still limited in their ability to predict complex interactions in the atmosphere and the ocean.
Absolutely. And your research highlights how quantum computers could be used to simulate these interactions with far greater accuracy,
Okay.
allowing us to develop more effective strategies for mitigating climate change. We could even use quantum AI to design new materials that are more efficient at capturing and storing renewable energy.
So it's not just about understanding the problem better, it's about having the tools to actually do something about it.
Exactly. Quantum AI has the potential to empower us to make more informed decisions and take more effective actions to address this global challenge.
Okay, so we've got climate change. What about something like pandemic preparedness? That's another area where it seems like we're always playing catch up.
That's a great point. One of the papers you shared discussed how quantum AI could be used to develop personalize vaccines and treatments for emerging viruses much faster than we can today.
Right.
Imagine being able to sequence the genome of a new virus and design a targeted vaccine within days or even hours.
That sounds like something out of a sci-fi movie, but it could be reality someday.
It's definitely within the realm of possibility.
Wow.
Quantum computers could also be used to simulate the spread of infectious diseases, allowing us to develop more effective strategies for containment and treatment.
So potentially preventing pandemics before they even start. That's a pretty powerful vision. It seems like the possibilities are truly endless.
They are, and it's exciting to think about all the ways that this technology could be used to improve our lives and address some of the world's most pressing challenges.
But amidst all this excitement, I think it's also important to acknowledge that this is still a very young technology.
Right.
And there are a lot of unknowns.
Yeah.
I mean, what are some of the potential pitfalls we need to be aware of?
You're absolutely right. While the potential benefits are enormous, we need to proceed with caution
Mm-hmm.
and consider the potential risks as well. One area of concern is the potential for unforeseen consequences.
Oh, yeah.
We're dealing with these incredibly complex systems,
Yeah.
and it's impossible to predict with certainty how those systems will interact with the real world.
So it's like we're opening up Pandora's box. We might find amazing things inside, but there could also be some nasty surprises.
That's a good analogy.
Uh,
It's crucial that we approach this technology with humility and a willingness to adapt as we learn more about its capabilities and limitations.
it sounds like we need to be prepared for the unexpected and be ready to course correct along the way.
Exactly. And we also need to be mindful of the potential for misuse.
Right.
As with any powerful technology, quantum AI could be used for malicious purposes.
Yeah, for sure.
We need to develop ethical guidelines and regulations to ensure that this technology is used responsibly.
Okay, so responsible development is key.
It really is.
But beyond that, what can we as individuals do to prepare for this quantum future? It all seems a bit overwhelming.
Well, one of the most important things we can do is stay informed
Okay.
and engage in conversations like this one.
Right.
The more we understand about this technology, the better equipped we'll be to navigate its potential benefits and risks.
So basically, don't bury our heads in the sand, embrace the unknown, and be willing to learn.
Exactly. And another important step is to focus on developing skills that are adaptable and resilient.
Okay?
The job market of the future is likely to look very different from the one we have today.
Right.
So it's crucial to be lifelong learners and embrace new challenges.
That's great advice. Well, I have to say, this has been an incredible deep dive.
It has.
We've covered a lot of ground from the basics of quantum computing to the potential for revolutionizing healthcare, climate modeling, pandemic preparedness, and even our understanding of the universe.
It's been a fascinating journey, and I'm grateful for the opportunity to explore all this with you.
Me too. And I'm especially grateful for all the research that you've shared. It's been a real eye-opener. So as we wrap up, what's the one key takeaway you want our listener to walk away with?
I think the most important message is that the future of quantum AI is full of potential,
Yeah.
both positive and negative. And it's up to all of us to engage in these conversations, make informed decisions, and work together to shape this technology in a way that benefits humanity.
Well said. And for our listener out there, remember this is just the beginning of your journey into the world of quantum computing and AI. Stay curious, keep exploring, and who knows, maybe you'll be the one making the next big breakthrough. Thanks for joining us on this incredible deep dive.